Okay, welcome to chapter 7. Here we go. 7.1, which is entitled Adding and Subtracting Polynomials. But a couple interesting facts here. Did you know the modern addition and subtraction symbols plus and minus were first used in Germany during the 15th century? They've been in use for less than 600 years. Can you imagine a time before we had plus and minus symbols? Ancient Greeks, such as Aristotle, used letters to represent numbers, so variables were being used long before addition and subtraction symbols. Interesting. All right, go ahead and do this warm up, some practice with signed numbers. Okay, so hopefully you got negative 15, negative 2, negative 52, and positive 38. Minus a negative, subtracting negatives like adding a positive. Here, remember, get used to the fact that we have like terms. You can always think of subtraction as adding an opposite or combining, right? Okay. And then down below, why don't you solve the system of linear equations by elimination? Pause the video and do it. Okay, so what I did was I multiplied the top equation by 3, and then I could either add or subtract. Let's see which I decided to do. I decided to do what? I decided to add. So the negative 9y and positive 9y canceled out. I get 6x equals 6, which means x equals 1. And then plug in. I plugged into the top one here, subtracted 1, so 3y equals 3, and y equals 1. So what's my answer? 1 comma 1. And then check it. Let's plug into the other original equation here. 3 times 1 is 3. Negative 9 times 1 is negative 9. 3 and negative 9, does that equal negative 6? Yes, it does. Check, check. All right. So you're a learning target. Go ahead. Say it out loud with me. I will learn what a polynomial is and then how to add and subtract them. I will be the GOAT of polynomials. And hopefully everyone knows that means greatest of all time. And you will be. Okay. You can be my partner, or I can be your partner, or both. We're going to write the expression modeled by the algebra tiles in each step. So you can see here, let's look at this and see if we can decipher this. These green rectangle pluses, there's 3 of them there. That corresponds to a 3x. Oh, these must each be x's. I wonder what the small yellows mean with a plus sign on them. Oh, they must be positive 1s. And then we have a plus sign here, which matches that. And then an x and a minus 5. All right, cool. All right. So let's see. What did I do going from step 1 to step 2? Hmm. Oh, yeah, I'm sure you got this. It looks like we just kind of rearranged things. We got things out of parentheses. We move this over here, and we move these over here. So we got like terms together. So it looks like we would have had 4x plus 2 minus 5. Okay, and then what did we do here? Looks like we put these together. I wonder why. Oh, positive 2 and negative. They cancel out. So we must have done this, 4x, and then put together positive 2 and a negative 2, and then had it 3 left over and negative 3 left over. And then those canceled out. So what are we left with? Looks like 4x, and then what? Minus 3. Yeah. Oh, cool. That wasn't so bad. Okay, so these bars represent positive 1x's, positive 1s, and negative 1s. Got it. Okay. All right, well, let's try this one. Let's see if we can do this one together. Ooh, we got new things. We got squares. Oh, that corresponds to an x squared. So that's a positive 1x squared. Got it. And then these still represent positive x's. Ooh, I haven't seen this red rectangle with a minus sign. It's the same shape as that one. Ooh, that must be a negative x. Okay, well, let's see. What do we have here? We have x squared plus 2x plus 2, and then a minus, so that's all grouped together, and then an x, positive x minus 1. Okay, what comes next here? What did we do? That stayed the same. That stayed the same. That all stayed the same. And then we did plus and negative, and then plus. Oh, I see. We distributed, huh? And now it's a plus sign there. Interesting. Okay. Let's see. What else do we do next? Looks like we move that over here and move those over there. Oh, we just rearrange things. So what would this one be? Are you thinking x squared plus 2x minus 1x plus 3? Yeah, good. That's what I was thinking too. Okay. Ooh. Oh, we've seen this before. Remember what that meant over here. We got this down, don't we? Yeah, this is going to be x squared plus x, and then in parentheses, a positive x and a negative x, and then plus 3. And then those do what? Oh yeah, cancel out. So what are we left with? X squared plus x minus 3. Interesting. So we're combining like terms and stuff. We know this. Okay. All right, let's go in a little different direction. If you want to take a break, this might not be a bad spot just to stretch for a little bit. We haven't done too much yet. But okay, a monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. Okay. So there's a monomial. That's just a number, right? A constant. Here's, if I just had x, that would just be a variable, or a product of a number and one or more variables like 3x or 1/2 ab squared, because the exponent's a whole number like 2 there. Negative 1.8 m to the 5th. Those are monomials. Interesting. Okay. Not a monomial. 5 plus x, right? There's some addition in there. 2 divided by n. Ooh, division. A number being raised to an a. Can't have that. And x to the negative 1. Oh, no, can't have to have a whole number exponent. Okay. So the degree of a monomial is the sum of the exponents of the variables in the monomial. Okay. So we can see here the degree of a non-zero constant term is 0. Okay, so the constant 0 does not have a degree. So 10, this is like 10 to the first, but there's no exponent. We could write it, and this maybe will explain this a little bit. If I wanted to, couldn't I put x to the 0 on here? And then we are looking at the exponent on the variable, because x to the 0 is just 1, and 10 times 1 is 10, right? So we don't need to do that, but that would explain why it's a degree of 0. And then 3x, remember this is like x to the first power, so that would be 1. Here, it's what a to the first, b to the second, so 1 plus 2 would be 3. Here the only variable is an m, and it's to the 5th power, so its degree is 5. Okay, all right, so, okay, find the degree of each monomial. Well, we're told they're monomials, so we don't have to worry about that. So what's the degree? Remember, it's the sum of the exponents on the variables. Well, that one is 2. Why don't you try these ones? Or second degree. 4, right? This one, 6. And this one, be careful. Think about what it would be. 0, right? That's like this one up here. We could put x to the 0 on there. Okay. All right, do some more of these. 4th. We got 5th because we add 3 plus 2. This one. Good. And this one, 0. Remember, we could always put x to the 0 on there. Okay, cool. All right, so polynomials. Poly means more than one, okay? A polynomial is a monomial. So monomial, even though it only has one term, is considered polynomial, or a sum of monomials. Each monomial is called a term of the polynomial. A polynomial with 2 terms is called a binomial, like a bicycle has 2 wheels, okay? Monomial, 1, right? Monorail, that thing, that Disneyland that you can ride from like the hotel and around the park and stuff, right? It's got 1 rail, okay? Again, binomial, bicycle, 2 wheels. 3 terms, a triceratops. Remember that dinosaur? It's the one that has like the 3 things here. It's got like the protective plate stuff. Or a tricycle, okay? Or a tripod, okay? So this would be an example of a binomial. This would be an example of a trinomial. By the way, we can have minus in there, right? Because it's subtraction is like adding a negative. Okay. All right. So the degree of a polynomial is the greatest degree of its terms. You look at each term individually. Whichever one of those terms individually has the greatest term or greatest degree, that's the degree of the entire polynomial. Okay. A polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. So you can see here, the exponent of this term is 3. This one, it's 2. This one, it's x to the first. This one is x to the 0. So it's decreasing from left to right. So that is what we would call standard form, okay? And when you write a polynomial in standard form, the coefficient of the first term is the leading coefficient. Okay, remember coefficient is a number that's being multiplied times a variable or variables. Okay, so in this case it would be 2. All right, constant term, we know that, right? It's not being multiplied by a variable, or you could say it's like x to the 0. Okay. All right, so let's practice all of those things. So we're going to write 15x minus x squared plus 3 in standard form. We're going to identify the degree and leading coefficient of the polynomial. Okay, standard form. Okay, what does that mean? Oh yeah, my notes right here. It means in decreasing order of the degrees. Oh, okay, so what's the biggest degree here? Well, this is 15x, so that's 15x to the first. That's the first degree. This one's cubed, that one's to the 0. So what would standard form be? Remember to take the signs with them. Good. Negative x cubed plus 15x plus 3. What would the degree be? Oh, the degree of a polynomial is the greatest degree of its terms. Well, 3 is bigger than 1 and it's bigger than 0, so it's 3. And how many terms? How many different blobs do we have that are being added or combined together? 3. So it's a trinomial. And what's the leading coefficient? Leading coefficient is the coefficient of the first term when it's in standard form. What's the coefficient on this term here? -1. Good. All right, so let's try these here. So go ahead and write -3z to the fourth in standard form. Wait a minute, it's only one term. Boom, done, right? What's the degree of this monomial? Good, it's a fourth. How many terms is it? 1. So what would we call that? As I said, it's a monomial. Good, it's one term. Okay, put this one in standard form. Well, it would be 5x squared comes first, right? Again, you take the signs with it. And then this is like negative x to the first. So that would come next. And this is like 4 times x to the 0 if we want to put that in. So it would go last. What's the degree of this? Hopefully you said second, right? Remember, you look at each term individually and take the biggest one. And how many terms do we have here? 3, which means we would call it a what? A trinomial. Okay, try this one. Hopefully you put that. The degree is to the 5th, and this is a binomial, 2 terms. All right, great. Okay, so write the polynomial in standard form, identify the degree and leading coefficient of the polynomial, and then classify the polynomial by the number of terms. So basically doing the same thing, except we're adding in this leading coefficient. Remember, the leading coefficient is the coefficient on the first term when it is in standard form, which means the exponents or the degree of the terms go down. Okay, so what's standard form for this one? Said that. What's the degree? Well, this is to the first. This is like 4z to the 0, so it's first. Leading coefficient is -9, and how many terms? 2, so it's a binomial. All right, try this one. Pause it. Okay, if we got that, third degree, -1, and it's a trinomial. And for C, hopefully you got that, right? Pretty straightforward. We have to learn these things. We have to learn, what these all mean and what they are. Maybe flashcards would be a great idea. Maybe writing out an outline or just rewriting kind of all the terms or definitions onto one piece of paper would be helpful. Okay, so we're going to add polynomials together. This really is not, you've actually been doing this, you just didn't know it. We didn't necessarily call them polynomials, but basically we're combining like terms, okay? All right, so to add polynomials, add like terms. You can use a vertical or horizontal method. I'm going to show you the vertical method, vertical format. If you like it, use it. If you don't worry about it. You can use a horizontal, which I think is what most people do, okay? So notice what we're doing. We're taking this and we're saying, okay, we're going to write the second part, although this is a different one, isn't it? Oh, no, it's not. They've rearranged it so that alike terms are vertical, right? So notice how the x cubed is not second anymore, it's first. It's right under the other 2x cubed term. Negative 5x squared, positive 2x squared. Blank here, that's that study tip. You know, if you don't have a like term there, leave it blank, right? We don't want to put the negative 1 over underneath it and get confused with all that. And then you literally just add down, okay? Horizontally, one way might be to combine your like terms and write them using parentheses. You're welcome to do that. Another way would be to distribute, and I'll show you this here. And then what I like to do is, just to kind of make things easier, I like to circle like terms. So I'll circle the two squared terms. Maybe I'll put squares around the terms that are to the first power. And maybe for the constants, I don't know, I'll put triangles, okay? You don't want to make it so messy that it's hard to figure out, but you get the picture, right? And then put them together, combine them together. 3x squared and positive x squared, 4x squared, 1x squared and 4x squared, 5x. Negative 6, positive 10, positive 4, okay? So this is my preferred way. So I'm really showing you 3 different ways. I don't really care which one you use. Use whatever one works best for you and that you're most comfortable with, that you feel is most efficient and leads to the least amount of careless mistakes. Okay, but I'm going to do these the way that I like to do them. Okay, so again here, I'm going to combine like terms. 4n squared, whoops, and this is kind of hard to do when you draw. Notice I'm circling the signs though, and this one is going to be by itself, but oh, here's some like terms here, right? 5 and 4, constants are always like terms. Okay, and then I'll combine those together. 4n squared and 2n squared make 6n squared minus 2n, positive 9. The instructions don't say anything about writing these in any kind of descending, what we would call descending order or in standard form, but generally that's a good idea, and you'll see why when we get into factoring later. And I think it's in this unit. Okay, what do you think the first step I would do here? To get rid of my parentheses, right? So what am I going to do with this minus sign? Yeah, we're going to have to distribute, right? So first I would distribute, and I'm not going to take the time to circle and square and stuff just because it is time consuming, but can you see the like terms? How many different pairs of like terms do we have? 3, right? 4x squared and negative 3x squared make 1x squared, or just x squared. Negative 3x and positive 1x make negative 2x. 5 and 8 make 13. Okay, why don't you go ahead and try these? And I'll just uncover them quickly now. Okay, so hopefully you got those, and if you didn't, then look them over, and I'm sure you can figure out why. Again, I really like my idea of like circling like terms. Not something, unless you're using this mess, not hard to do, doesn't take all that long, and really can help you straighten things out. Okay. All right, let's do some more problems with this stuff. Same type of stuff. Okay, a penny is thrown straight down from a height of 200 feet. Okay, so you can see that up here, 200 feet up. At the same time, a paintbrush is dropped from a height of 100 feet. And you can see the paintbrush right there, 100 feet. And it looks like it's double, so that's 200 feet. The polynomials represent the heights and feet of the objects after t seconds. And you might be wondering, like, where did they get these polynomials from? This has to do with acceleration and velocity. But notice here, the constant is 200. We're going to learn kind of all about this stuff. This is actually would be the shape of a parabola that opens downward. And 200 is kind of like its top point, what we would call its vertex. And for this one, its vertex is 100, right? So it's going to be falling down like that. Anyway, we'll get into that later. But what we need to do is take this height and subtract this height from it, right? Because this height is all of this. If I subtract this off, it tells us the difference between the two. Okay, So yeah, that's exactly what we would do. And then we would need to do what here, right? We would distribute, good. So it becomes plus 16t squared, negative 100. Combine your like terms. Oh, look at that. The t squared terms do what? They say adios, arrivederci, and they disappear, right? They're opposites. And so what am I left with? Negative 4t plus 100. Okay, interpret the coefficients of the polynomial in part A. Okay. Well, as the value of t increases by 1, the value of negative 40t plus 100 decreases by 40, right? Think about it this way. If t is 1, or if t is 0, then this is equal to 100, right? If t is 1, negative 40 times 1 is negative 40, plus 100 is 60. This means that the objects become 40 feet closer to each other each second. So minus 40 represents the amount that the distance between the objects changes each second. So each second, they're getting that much closer together. Okay, what if the polynomial negative 16t squared minus 25t plus 200 represents the height of the penny after t seconds? So we're basically just changing this to this. So still subtract the same thing here for the paintbrush. And we get that. So what does this mean? Okay, 100 represents how far they were to start with. The negative 25 represents that the penny and the paintbrush become 25 feet closer each second. Okay. Write an example of the sum of a trinomial and a binomial that is a binomial. Okay, so you need to sum, addition, come up with a trinomial and a binomial that results in a binomial. Here's what I did. And you can see that what's going to happen with one of my terms, once I distribute, what's going to happen to the 2x and negative 2x? Gone, which leaves me with just x cubed minus 2, which is a binomial. What's the degree of this binomial? Hopefully you said 3. And what's the leading coefficient? 1. Okay, well, that pretty much does it for 7.1. So you've got an introduction to what polynomials are, how to combine them together, which means adding and subtracting. And we're off to a good start. Congrats. Bye.